Hello students, this is Indrani ma'am from SIP Rasayan. In my previous lecture, I have explained some questions on acidic strength of phenolic compound. In this video also, I am going to explain some more questions on this topic. First question is, the correct acid strength order of the following compounds is, 4 compounds are given. This is orthonitrophenol, this is paranitrophenol, this is metanitrophenol, and this is unsubstituted phenol. We know at ortho and para position, nitro is having minus I effect and minus M effect. Both are electron withdrawing effect. Here also same thing, minus I, minus M. But at meta position, only minus I effect will operate. Here resonance effect will not operate. Now write the corresponding conjugate bases. These are the corresponding conjugate bases of these phenols. Now see, these and these phenoxide ions are more stable than this phenoxide ion because electron withdrawing effect of nitro group. Therefore, these 3 are more stable than this, and A, B, C are more acidic than D. So, D is least acidic here. Now see, for metanitrophenol, only here minus I effect will operate. But for this and this, minus I minus M effect will operate. So these 2 are more stable than these. Therefore, in A, B and C, C is least acidic. Because the more stable the conjugate base is, the more acidic is the parent acid. Now out of A and B, which one is more acidic? For ortho and para-nitro, both are having minus I and minus M effect. But in orthonitrophenol, this type of intramolecular hydrogen bond is there. But in paranitrophenol, since nitro is far apart from OH, so this type of intramolecular hydrogen bond is not possible. Due to this intramolecular hydrogen bond, it will exist in this form more than this phenoxide. So removal of H plus is difficult here comparative to paranitrophenol. Therefore, paranitrophenol is most acidic, then is orthonitrophenol, then is C means metanitrophenol, and last one is unsubstituted. This is the acid strength order. Now see, between these 2 compounds, which one is more acidic? Both of them are phenol derivative. With respect to phenolic OH, at ortho position here 2 methyl groups are there, at para position here 1 nitro group is there. Here with respect to nitro, at ortho position 2 methyl groups are there, and with respect to nitro at para position OH groups are there. So how to compare the acidic nature? First you have to write the corresponding conjugate bases. So these 2 are corresponding conjugate bases. Now see, the most important condition for resonance is that the involved atoms in the structure must be in the same plane or nearly in the same plane. If the involved atoms means atoms under resonance are not in the same plane, then the involved orbitals are not parallel to each other. If these are not parallel to each other, then resonance is not possible. If resonance is not possible due to this reason, it is called steric inhibition of resonance. Here, 2 methyl groups and nitro group, they are very close to each other. So, due to steric crowding, nitro group will be out of the plane of benzene ring. So, resonance is not possible here. So, O minus will not be stabilized due to minus M effect of nitro group here. But here, CH3 groups are ortho with respect to less bulky OH or O minus. So, here steric crowding is not that much, therefore all atoms will be in the same plane and O minus will be in conjugation with nitro, means minus M effect of nitro will operate, and this conjugate base is more stable than this conjugate base. Therefore corresponding parent compound is more acidic here. So this is more acidic than this due to steric inhibition of resonance. So you can note down, due to steric crowding between 2 methyl and nitro group is not in the same plane with benzene ring. So minus M effect of nitro will not operate on O minus, but here minus M effect will operate on O minus and this conjugate base is more stable. Therefore, corresponding acid is more acidic. Next question, the decreasing order of pKa of the following compound is, 4 compounds are given. This is orthocresol, this is metacresol, this is paracresol and this is phenol. Now what we have to do? First we have to write the corresponding conjugate bases. These are the conjugate bases. Now see, methyl at this position is having plus I and positive hyperconjugative effect. Both are electron releasing. At meta position, hyperconjugative effect is not there, but electron releasing plus I effect is there. At para position, like ortho, plus I and positive hyperconjugative effect is there. And this is unsubstituted. So, these and these will increase electron density on oxygen atom. Therefore, conjugate base will become less stable compared to phenoxide. If conjugate bases are less stable, then parent compounds are less acidic than phenol. So here most acidic is phenol. Now between 1, 2 and 3, what is the acid strength order? Now since it is ortho position, plus I effect is more here because plus I effect depends on distance, and here since it is para position, here plus I effect is less. Therefore, stability order of conjugate bases are, fourth one is most stable, then number 2 here only plus I effect is there, then number 3 because here less plus I effect is there compared to 1, and then 1. Therefore, acid strength order is also this one. Now, acid strength is directly proportional to Ka. Ka means acid dissociation constant, but it is inversely proportional to pKa because pKa is equal to minus log of Ka. Therefore, decreasing order of pKa value is inverse of this one. So, this is having highest pKa value, then 3, then 2 and then 4. Just reverse order. So, pKa value will be reverse of the acid strength order. Next question, the correct decreasing order of acid strength of the following compounds. 4 compounds are given. So, first what we have to do, we have to write the structure of the corresponding conjugate bases. We know this is phenol, so phenoxide. Now here at phenol at para position, this substituent is there. Here at para position, nitro is there, and here at para position, this group is there. Now this group is having electron releasing plus I effect and plus M effect. Nitro is electron withdrawing. It is at para position, so both it is having minus I minus M effect, and this is isopropyl group. At para position it is having positive hyperconjugative effect plus I effect. So nitro group will abstract electron density from that oxygen, and that phenoxide is most stable. So corresponding acid is most acidic. So first one is most acidic is C. Then these are electron releasing. So next one is A. Stability of the conjugate bases is this one. Then between these two, it is having hyperconjugative effect and plus I effect at para position, and here it is having plus I and plus M effect, and we know resonance effect is more than hyperconjugative effect. So this effect will increase electron density on oxygen more. So it will become less stable compared to this, because here hyperconjugative effect is there. So next will come this one, and least stable is this conjugate base, number B. So if this is the stability order of conjugate base, then acid strength order will be same also, because stability of conjugate base is proportional to acid strength of the corresponding parent compound. So this is your answer. In this video till this, if you like, please subscribe. Thank you for watching.